Okay, this is video number 2 on completing the square. Page 580 in your textbook would be a good reference for you to look at. We're just going to do a couple of practice problems here together. So let's just go ahead and get started. Our first ones are just a little bit of review. Remember when we square binomials, x plus 3 squared, we would just write out the binomial side by side and then FOIL to get x squared plus 6x plus 9. And if you recall from your second polynomial test, we said there was a trick to that. You square the first term, square the last term, and then double the middle term. So negative 5 plus negative 5 would be negative 10x. And so you can remember that little trick. If you would like to practice a little bit more, there's a few other problems that you can practice. But we're going to move on and we're going to do the inverse of that. Okay, but before I do that, I want you to notice something about the end numbers of each of these polynomials. What is special about 16, 9, 81, 1/4? They are perfect squares. We're talking about completing the square, so it's a good idea for you to know what perfect squares are. Remember, those are like 1 squared is 1, 2 squared is 2, 3 squared is 3, and so on. Well, the square root of 16 is 4. If I double 4, do I get 8? So I'm looking at x plus 4, that binomial, squared. Okay? What's the square root is, now this one has a is a term and 9 is a term. 9 is a perfect square. Is my a a perfect square? Yes. What's the square root of 4? 2. So we're going to have, we have a 2x. This is negative, so it's going to be minus 3. 2x minus 3 squared. How about down here? The square root of 81 is 9, so it's going to be m minus 9, because this is a minus here, squared. Ooh, this is a fraction. Just FYI, because we're going to get into this. When you square root a fraction, it's the square root of 1 over the square root of 4, which would be 1/2. Okay? All right, so let's move into completing the square. Find what C should represent to complete the binomial squared pattern. Okay, remember we squared this term and doubled it to get this. Well, what's half of 10? So 10 divided by 2 is 5. 5 squared is 25. Okay. Half of 14, 7. 7 squared, so C is 49. Okay. I'll do one more with you and then you can try the last 3 on your own. What's 24 divided by 2? 12. What's 12 squared? 144. Notice all of these numbers are what we call perfect squares. You try 12, 13, and 14. And make sure you show those to me after the video. Okay, so now we're going to move on and look at 580 and the examples there. So solving quadratics using binomial squared. If you haven't finished those 3, you may want to pause right now. This problem follows example 2 on page 580. So let's look at this. We have, remember our standard form, ax squared plus bx plus c equals 0. We talked about that last time. So what happens? How are we going to get this to be a perfect square? Well, remember what we did? Remember what we did back here? We divided it by 2, and then we squared it. So we're going to take our b term, divide it by 2, and then square it. Okay? And we're going to then add it as our c term. But if I do that in an equation, I need to make sure that I add it to both sides. Okay, so here we go. My b term is 9. So 9 divided by 2, that quantity squared. Now you can leave it as a fraction or you can put it as a decimal. I'm going to leave it as fraction. So x squared plus 9 halves I'm sorry. Not x squared, just x squared out. No, I'm not confused here. X squared plus 9x plus 9 halves squared equals 136 plus 9 halves squared. Remember, this is an equation, so I have to do the same thing to both sides. Okay? So now, I'm ready to have this problem, which becomes 9x squared plus, x squared plus 9x plus 81 over 4 if you want to divide it out. Or, since you know now this is a perfect square, this number squared, then you know that this becomes my double bubble of x plus 9 halves and x plus 9 halves, or the quantity x plus 9 halves squared. Okay, then over here I have 136 plus 81 over 4. Now I need to add these together. 81 fourths plus 136. So we can turn 136 into fourths. That becomes 544 over 4. Plus 81 over 4. Okay? So over here I still have x plus 9 halves squared equals 544 fourths plus 81 fourths. Becomes 625 over 4. Now, you can recall from our last video, if this is squared and this is, and I want to inverse that, I take the square root. So the square root of the quantity x plus 9 halves becomes x plus 9 halves equals the square root of 625 over 4. Or the square root of 625 over the square root of 4, which becomes 25 over 2. Okay? Now, how do I find what x equals? So I have x plus 9 over 2 equals, this is positive and negative, positive 25 over 2, and x plus 9 over 2 equals negative 25 over 2. Then when you subtract, I think you find that x equals 8 or negative 17. Okay? Let's try this next one. I think this one, it might not be quite as confusing because it's not going to be a fraction. So I'm going to go rather quickly. Okay, remember b over 2 squared. Okay, 6 over 2 squared. 3 squared, 9. Okay, so now I'm adding 9 to both sides. M squared minus 6m plus 9 equals 27 plus 9. Factor this guy. It becomes m minus 3 squared equals 27 plus 9, 36. Okay? Square root, m minus 3 equals positive or negative 6. So m minus 3 equals 6, and m minus 3 equals negative 6. Therefore, m equals 9, negative 9, no, 9, I was right the first time, 9 or negative 3. Okay? Oh, I just realized I made a big error. I wrote 27 instead of 247. So, you might have come up with a different answer, but 27 worked out just fine. Okay? All right, let's move on here. What happens when I'm in standard form and it's already equal to 0? Can I take this equation and make it look like this one? You betcha. X squared plus 8x minus 30. Oh, this is what I get for trying to rush. 20 equals 0. Add 20 to both sides. X squared plus 8x equals 20. B divided by 2 squared. 8 divided by 2 squared. 4 squared. 16. X squared plus 8x plus 16 equals 20 plus 16. This becomes x plus 4 squared equals 36. X plus 4 equals positive or negative 6. This was the square root step. X plus 4 equals 6. X plus 4 equals negative 6. And I subtract 4 from both sides of that. I get x equals 2 or negative 10. Okay, I think you have a few more. You can try those on your own and have me check.